Hello. Now, I've had an awful lot of questions this week about how you might go about starting an archaeological survey. So I decided to cycle up to some round barrows near to Corfe Castle and have a think about those first important steps to beginning a survey. Now, the very first thing you do when you get to a site like this is just have a look, have a wander around, see what features you've got in the landscape to get a sense and impression of the archaeological lay of the land. Once you get your eye in, it becomes quite easy to see features that are anthropogenic, made by people, rather than those slightly more undulating, slightly more uneven natural features. So the round barrows here really stand out. The first thing I did though to find this site was have a little look on an ordnance survey map, and I could see that there was a bridleway right next to this round barrow cemetery, so it was perfect to come and have a look at. There are lots of ways you can go about recording features like this, from lo-fi, cheap and inexpensive, all the way up to high-tech options. The most basic of which would be some tape measures, simply pace out the site and tie it into some sort of local reference point. And the more advanced end of the scale, obviously, is to use for example, a network-enabled global positioning system. And anywhere in between, really, you could incorporate total stations, theodolites, dumpy levels, auto levels, a range of tools really at your disposal, and picking the tool set really depends on the type of site you're looking at and the type of equipment you have at your disposal. Now, right now, I don't have access to the equipment store that I normally would, so if I wanted to survey this site, I would have to do it with tapes, offsetting, laying out a site grid and recording offsetting from baselines. To do that, you need very basic equipment, tape measures, grid pegs, clipboards and pens, paper, a good sense of scale, and you can produce quite an accurate plan. The first step though, when you get out into the field, if you're not relying on GPS technologies, is to figure out how you're going to orientate your survey and reference your survey to something in the real world. Now, doing it in the most basic sense, i.e. with tapes and measures, I would look around me and see if there are any fixed points that I can identify on Google Earth or on aerial imagery or on Ordnance Survey maps. Now, the footpath is a good one, but also I can see a line of pylons in the distance which I could triangulate from. There are some trees nearby, so there are enough reference points. There's even a mile marker just about 100 meters to the south of me that I could use to reference myself to the real world. And it's just a case of annotating that on your plan as you go. So once you've identified a way of referencing yourself, it's simply a case of laying in baselines, reference lines, and then mapping from that. Now, there are lots of how-to videos about that on the internet, so I'm not going to bore you with the details, but that's really the first step to doing a basic archaeological survey. Now, if you did have access to high-tech materials such as a total station or a GPS, they would be excellent tools to use on a survey like this. Likewise, you could easily go and look at the Environment Agency's LiDAR surveys and produce one from the comfort of your desk. Now, I would say, however, that although you may get a very nice topographic plan from a LiDAR survey, you don't experience the feature in the monument in the same way as you would if you were surveying it on the ground. So the actual act of getting out here with tape measures, with GPSs, with total stations, and actually identifying where a clear break of slope is, where the feature begins and ends from an anthropogenic perspective, gives you a sense and a taste of a site in a way that you never get remotely. So while remote sensing is useful and you can produce highly accurate plans from it, actually being on the ground and conducting an investigative survey is really valuable. Now, if I was doing this in a more high-tech fashion, the basic principles would remain the same. With a total station, you still need reference points to work from, and it's still a good idea to have baselines to facilitate a representative survey of a site. If I was using something like a network-enabled GPS, which would give me a couple of center accuracy by communicating with both satellites and the SmartNet system, I would do a survey basically walking over the site in transects, taking points and records as I go. That would give me the 3D character of the site, which I could download and put into a geographic information system. But I would also want some interpretive detail. So I would either do a supplementary sketch plan annotated with what I can see in the landscape, or better yet, in a digital sphere, I would use the line functions within the GPS to draw interpretive lines in real space that I could download and supplement my topographic data. So I would use both interpretive, ultimately a digital sketch plan, and the more quantitative 3D data that we've gathered by doing the transects. Now, looking at a site like this, which is a series of discrete tumuli or barrows, I would probably be inclined to lay a straight baseline along one axis of the site, probably along the footpath here, so I could triangulate to some nearby features in the landscape, and then I would do some offset measurements to measure the dimensions of the site. And once I've got the broad dimensions sketched in, I would start to draw in some of the other breaks of slope, some of the other features, the depressions on the top, even the badger barrow that seems to be digging its way into one of these barrows, and I would start to flesh out the character of the sites with key interpretive details, i.e. where does the barrow begin compared to where does the topography begin, for example. And then I would start to flesh it out with hashes and other illustrations to give a sense of the 3D character of the site, and that would give me a broad archaeological sketch plan that I could use as a basis for future work. I'd probably as well, I'd take a profile of these to get a bit of a sense of that topographic character, and I'd do that by laying a baseline along them, and I'd raid the archaeological stores and get an auto level, and I would use that to record topographic points along the long axis of these features, giving me a profile of the barrows. Key considerations when planning your survey are things like finance, access to resources, and what exactly is it you're trying to achieve. Now, if it's a picture perfect micrometer accurate and precise survey and you've got all the money in the world, then you may take a laser scanner out, you may reference it and control it with your GPS, or you may even commission a low-level aerial flight. You may go at it with drones. But if you're on a tight budget and you don't have a huge amount of money and resources at your disposal, but you want a good interpretive plot, you can still do it with fairly basic technology. More recently, drones have been used quite intensively in surveys like this, using something from structure, from motion, or multi-image photogrammetry. Now, I'm going to do another video on the specifics of that hopefully soon, looking at it from a terrestrial perspective, but the same principles apply. Basically, that involves flying over a site or a feature with a drone, taking numerous photos, and then using specialist software to stitch those into a three-dimensional point cloud, which you can use to construct a topographic model. Now, I've used this quite a lot on site recording to supplement basic sketch plans and hand-drawn recordings, and actually it's very nice to put a 3D model into a geographic information system, look at it from through a variety of different processes, things like slope, local relief models, digital terrain models, and then using that to complement and facilitate a more traditional interpretive plan can be a really nice way of going about recording a site. Now that's just the basics really of the beginning of survey. There's an awful lot more detail, and I will post more videos in time. But there are a number of key resources you can go and look at to assist with planning a site. The English Heritage Guidelines are very good as a basis for beginning an archaeological survey and kind of getting your head around the key steps and the key processes. But ultimately, the main things to remember are any archaeological plan must have some sort of spatial reference, so you know where it is in the real world. It must have a scale, and it must represent the character of the site. These are really important, and it allows you as the surveyor, as the archaeologist, to really understand and get a feel for a site in a way that you simply can't by either just having a casual look around, or indeed by looking at it remotely via LiDAR or maps, etc. So I hope that's helped. It's a very broad introduction, but as I say, there are a lot of good resources out there to help build a skill set.